Hi, everybody. Welcome to this afternoon's webinar. I'd like to welcome you all. We've also got Andy Gillies with us, who I'm going to introduce. So for those of you who don't know, Andy is a past president of the BOHS and has been a friend of the AOH for many, many years and attended a number of the AOH conferences. So you all might remember from that. And one of his areas that he has specialised in over his life as a hygienist is how we can control exposures down to as low as reasonably practicable, so to make it safer for everyone to work. I've known Andy for the odd year or two. Andy, as you can all see, has been worked in a number of industries, including steel and chemical manufacturing. And he's been a member and a leader of this COMED working group since it started. He's going to talk a little bit about the history, and he's actually been presenting papers and workshops on this. This is a system that was supposed to have been up and running by now, but due to, like many things, COVID, it just hasn't made the, got there quite yet. So I'm going to go off camera and I'm going to hand it over to Andy. Welcome to the AOH webinar series, Andy.
Great. Thanks, Sue, and thanks for that great introduction. And also thanks to you and the Institute for inviting me to present this workshop on COMED today. Before I begin, I should explain, as Sue alluded to, that the COMED tool is still a work in progress. It's still under development. So it's not been finalized and it's not publicly available yet. So what I'm going to show you today is a snapshot of the current status of the database, but that will give you a good idea in terms of its structure, how it works, and what its potential and capabilities are. COMED, for those of you who haven't come across the term before, is an acronym. It stands for Control Measures Efficiency Database. Sometimes confused with COVID, so just be aware of that. But it's actually a tool that's focused on the most important part of an occupational hygienist's work, and that is ensuring effective control of exposure to hazardous materials and preventing people from suffering work-related illness and deaths. So there are two main aims of today's webinar for me. One is to give you a good basic understanding of the COMED database and how it works. And secondly, to show you how you individually may get involved and contribute towards the ongoing development and improvement of the database. Agenda for the webinar is pretty straightforward. So after a general introduction with some historical context to show you how we got to where we are and how things started, then I'd like to just walk you through the different key elements of the database and show how they all interact together and explain one or two features of COMED. And that will then lead on to some live demonstrations. I'll sign in to my account on the COMED website and use a couple of case studies to show you how the database can be used and what its capabilities are. And then there'll be a short summary wrap up at the end and hopefully time for one or two questions and answers. So we've got a busy few minutes ahead of us. The next slide shows you our vision for COMED. We want it to be regarded by users as the premier database containing reliable and objective and trusted data on the efficiency of exposure control measures. What makes COMED different from other tools, I think, in this regard, is that it comes from a unique collaboration between an academic institution, the Fraunhofer Item Institute, based in Hanover in Germany, with a small team under the leadership of Dr. Stefan Hahn, the BOHS, the British Occupational Hygiene Society, and also a team of individual occupational hygienists, practitioners, experienced, professionally qualified hygienists who are contributing on an ongoing basis to COMED. So the database itself is comprised of a whole series of what we've termed data sets. Each data set has been taken from published information in peer-reviewed literature in the main, but also we have a number of entries from what people refer to as the grey literature, information that's not been published in peer-reviewed journals, but is still really good quality and very useful information that's being contributed by our individual members. This next slide shows some of the key features of COMED. We want the COMED database to be a one-stop shop for useful information on efficiency of common control measures. Just a quick reference here to the second bullet point. For those of you who haven't come across the term RMM, bit of legalese that's derived from the REACH regulation over here in Europe, the Registration, Evaluation, Authorization of Chemicals regulation. RMM is the term they use, standing for Risk Management Measures, to mean essentially what we would commonly refer to as exposure control measures. So one thing that we're very keen on within the COMED community is that the tool has been designed right from the outset and developed with the active input of experienced occupational hygienists. So we think we've developed something that's very scientifically robust, but at the same time is very practical and easy to use. So let me just take you back a few years to show you where this tool came from. Back in 2015, the International Occupational Hygiene Association held their annual conference in London to coincide with the BOHS annual conference. And a good friend and professional colleague of mine, Alvin Woolley, and I presented a workshop looking at this topic. And we found some really interesting findings as a result of the workshop. The workshop we ran again a number of times at subsequent annual conferences and BOHS regional meetings, and found the same thing each time. So we presented the audience with a number of scenarios of processes, common processes with exposure controls, and we had exposure data for those scenarios, both without exposure controls in place and after the effective implementation of exposure controls. And we asked everybody for their best estimate in terms of how much would exposure be reduced by following the application of the exposure control. And invariably, we found vastly different estimates of control efficiency from different teams of very experienced professionals, very well qualified hygienists, risk assessors, and others who had many years of experience of looking at exposures in different situations. But we all came up with our professional judgment and came up with very different results. It was clear there was a big evidence gap in the literature in terms of how effective and how efficient exposure controls were. And at that time also, the REACH regulation was just really rolling through its implementation phase on registration. And that regulation required a lot of use of exposure prediction models like Equitok TRA or the ART model or COSH Essentials. And those exposure prediction models all contained rough estimates of efficiencies of common exposure controls, which were really quite misleading in our view. So we went to BOHS Council, presented our findings, and a BOHS working group was set up with input from Fraunhofer-Eiter right at the beginning. And that working group reported through to BOHS Council in September of 2019, just before the pandemic hit. Fraunhofer took over the leadership. So this is how we have structured ourselves in terms of the work that's been done to date. We have a management group, which is headed by Dr. Hahn, and I'm a member of the management group with a few other people. And that coordinates the work of three main working teams. One team of volunteers who are involved a lot with inputting new data sets, looking at evaluating the data and the information that's provided. We have a separate validation team that focuses on key issues of ensuring good quality of the data and the information that enters the data set. And we have a third team of IT professionals who look at the ongoing programming, development and maintenance of the database itself. Right, this is a busy slide, but hopefully the schematic allows you to see how the different pieces all fit together. So if you start on the left-hand side as you look at the screen, the data sets, that's the foundation of the database. Each data set describes a process with a control measure applied, and the key thing is that each data set comes with exposure data. Hopefully, ideally, we'd have personal exposure data before the control measure was applied and after the control measure was effectively applied. The second part of the database is the query function, and that allows you to interrogate the database using a number of screening tools. So you can pick on a particular process that you're interested in, or a specific type of control measure, for example, or the year in which the work was carried out, those sorts of things. And after the query aspect, you then go into the analysis function, where the database itself will calculate for you the efficiency of the control measure, and it will summarize the performance and give an easy to understand result in the form of an efficiency ratings ladder. This is an idea we're still working on and refining. And finally, on the right-hand side, there are a number of control advice sheets which are being developed to try and pull out and summarize in an easy to understand form the key information that's contained in the database. This slide shows you the current iteration that we're working on, as I mentioned, of the efficiency ratings ladder. We have categorized the efficiency of control measures for a particular process in one of 5 categories, A to E, so you can get a quick feel for where in the hierarchy in the efficiency ladder your control measure fits. We're looking at refining the measure in terms of the adapted efficiency rather than just the efficiency reported from all the data sets, by looking at different elements of the weight of evidence that might improve your estimation. So that's work in progress. The control advice sheets, here's a quick example of one that's been worked on. They will be intended to be used by the end user of the control measures themselves. We have tried to design these control advice sheets to be easily understood, and we're still working on getting the right format and including the right information there. Okay, so that's the key elements, the main parts of the COMED tool. What I'd like to do now is to take you onto a live demonstration of how the database works through 2 case studies. The first one is looking at MIG welding, a simple operation with use of on-torch extraction. And the second is grinding operation with an angle grinder, again using on-tool extraction. So I'll first briefly describe each scenario, and then we'll swap over and go into the database, and I'll walk you through it there. So the first case study, MIG welding. This is an example of grey literature. This was actually some work that I did and I submitted to the database some time ago. It was a study where some MIG welding was being carried out on some stainless steel bars, a well-ventilated open workshop. There's one guy working, no activities being carried out in the adjacent areas, and we had repeated breathing zone measurements before and after use of the on-torch extraction. The second case study is looking at respirable crystalline silica exposure of stoneworkers, monumental masons doing repair work on old monuments in Ireland using a 5-inch angle grinder. This is some work done by Catherine Healy and colleagues, which was reported in the Annals some time ago. And she obtained exposure data both for total dust and respirable crystalline silica of work done without on-tool extraction, and then with 4 different types of shroud, all fitted to an extractor. So if you just give me a moment, I'll go into the database and then we'll walk through the 2 different case studies. This is the opening page of the COMED database. I've just signed in to the website. As you can see across the top where my cursor's moving, you've got a number of different entry points. The home button includes some information about the COMED database and sponsors and supporters, etc. The data entry tab allows you to open data sets. So if I click on that, you then get a list of the individual data sets that are available. If there's a drop-down menu here under process, so if we select grinding, for example, and search for papers dealing with grinding, then the grinding related data sets are highlighted in red, so you can quickly go through to them. You can add a new data set. So if I click on that, you then get this page where there are boxes, both drop-down menus and free text boxes for supplying information on the process, the engineering control measure, critically the exposure data, the type of study that's been carried out, what measurement technique has been used, and further information, and then the actual summary of the results, exposure with the control measure off and on, and any further information, and then references and data reliability. If you have entered a data set, then you will be given authorization to edit that data set, which will then be moderated by the data quality guys. And there's also a tab of references, all the references that underlie the data sets that we have. The analysis function and the query function is then something that comes into play once you've selected the data sets that you're interested in, and the control advice sheets come later. So if we go back to the data entry tab, and I select open data set, the first case study that I mentioned was data set 93, which you can see listed there. So if I open that, select and open it, here you see the page where all the information that was originally submitted is summarized. Now, at the top, you see publication type. There are 3 different categories that we've defined. Published data is peer-reviewed literature and a summary of the information from that. Unpublished industry data, and this is an example, is information that's not been through the peer review process, but has been through the evaluation and data quality assessment process for COMED. So it's been regarded as of sufficient quality to be included in the COMED database. And the third category is supporting data for the control advice sheet. So it's things like review papers that summarize original work from a number of different authors. The working process here is welding, MIG-MAG welding, carbon mild steel. Additional information tells you that this was a simulated welding activity carried out without extraction and then with extraction. If we look at the information on the engineering control measure on torch extraction, we have the name and manufacturer's name of the specific welding gun with on torch extraction that was being used. The extraction flow rate is specified. Some useful general information on code from the input. And then we've got contextual information on the exposure measurement. So it was personal exposure data as opposed to other types. The measurement technique and further information was included. And here we have the actual results, a mean of 3 repeat samples in each case, before and after the exposure control was applied. And then just some references. So if we go to the analysis function, because we're interested to see how this information, so if you remember, we've calculated 79% efficiency of this on torch extraction. We want to know, is that a typical finding? How does it compare to other work? So we go to the analysis function and you're presented with this screen, and you can see we've got drop-down menus here for a number of different categories. So for the process, we would select welding. For the engineering control measure, it would be LEV. The sub-process here would be MIG or MAG welding. And the subcategory would be on torch extraction. So if we search for that, we find there are 27 entries on fitting those screening processes. If, for example, we didn't specify an engineering control measure, nor the particular type of welding process, and we searched, we get 42 entries. So you can really zero in on the type of engineering control and the type of process that you're specifically interested in. So we'll keep with those selected tools, 27 entries. And each entry has a measure of overall efficiency, but they vary quite a lot, and it's quite difficult eyeballing that list and understanding what the data tells you. So if you click on the analysis button, you then get these histogram plots that show you the individual data sets, each one individually, and it also specifies the average efficiency for all of those data sets, the 27 entries, as nearly 80% efficiency, plus or minus 17% standard deviation. And you can see there's wide differences between some of the individual data sets. The next distribution plot, another histogram plot, shows you it's fairly Gaussian type distribution, with most of the data points falling between 75 and 90% efficiency. We can do further screening. So if we're only interested in data where the data quality has been deemed to be of good quality as opposed to medium or poor quality, and if we filter that and analyze that, then we see that the good data is a lot more consistent. And in fact, the overall efficiency is 86.7% with a smaller standard deviation. And you can then compare your selected data, which is this box plot here, with all data. And you can see there the difference is that the range between the lowest and the highest, or the 25th percentile, 75th percentile, is much tighter than the all data set. So some interesting little things you can play about with there. And if you get to that point and you want to summarize that information in a printable form, you can press this PDF report, and that shows you the efficiency ratings ladder that we mentioned before. It reproduces the histogram plots, and then it gives you a list of all the relevant references that are covered by. Right, if we look at the second case study, which if you remember was the stonemasons grinding with a 5-inch angle grinder. If I go into the data sets here, then that covers a number of different data points from data set 2 through to data set 9. So this is one piece of work that's been published in the annals, but in order to present the information in a usable form for the COMED database, then we've split it into 4 different types of shrouds. So there's a flex grinding shroud, and we look at the information on total dust and respirable crystalline silica. A dusty grinding shroud, the same thing. Dust muzzle, the same, and a Hilti. So if we just randomly choose the Hilti dust extraction hood, respirable crystalline silica, so we got the same information here that we had the same page as before. So drop down menus for lots of different elements, but then free text information on lots of things. And then if we go into the analysis function here, we can select for grinding. And with grinding, we'll pull up 41 different entries, including the entries that we're particularly interested in, the Healy et al. So the category or the work that we were looking at was using the Hilti shroud with extractor and filtration system. And the workers there, Healy and Co. et al. Produced a result of 97% efficiency of that shroud and extraction with on-tool extraction for grinding. So how does that compare with all of the beg your pardon, with all of the data? There again is the plot that we have of all the individual data points And here you can see quite a lot of variability of the efficiency of controls, but most of the results have been greater than 95% efficiency. So with our 97% efficiency there, we're in line with a lot of other studies. So that gives you increased confidence in the reliability of it. One thing I didn't show you before is with each data set that's listed in the analysis page, then you can quickly recall all of the data input for that by clicking on the open button. And that brings up this page here. So again, it will summarize all of the relevant input information in terms of working process, engineering control measure, contextual information, data set reliability, etc. So that's quite useful to have immediately to hand if you're doing some analysis. Right, one of the things I haven't shown you so far is the control advice sheets. So they're listed. At the moment, we have a very small library, so this is definitely something that we need to put more work into. But here is an example of what the control guidance, the control advice sheet would look like for a particular process, in this case, grinding with on-tool extraction. So you have some useful photographs to show you the sorts of things you're talking about, some basic information, including exposure limits on relevant hazardous substances. And then in terms of the control measure, we've listed in bullet point format what we've termed the key performance characteristics, information that you need to understand in order to apply the control measure effectively. And we've also tried to tease out factors that it would improve the efficiency of the control and factors that actually reduce the efficiency of the control. And that kind of spills over a little bit into the behavioral aspects of how equipment is used and how the person in the working environment might impact and affect the way the controls are measured. Okay, so that's a pretty quick run through the COMED database. So hopefully that's giving you a feel for how you can run through and work on the database. So one thing I mentioned at the beginning is the way that we've managed to incorporate and build up a really good active network of volunteers to contribute to the ongoing development of the database. And that's really one of the major strengths, as we see it, of COMED. Many of these guys are based in the UK, but we have people from other European countries as well. And the actual location is irrelevant because all of the work can be done online. There's lots of different ways that you can get involved and contribute, as you can see on this this slide here. So if anybody finds this this idea and this development interesting and wishes to make their contribution, you'd be very welcome indeed. So as a final summary, just to wrap up, we believe the group who are involved in the development and work of the COMED tool, that COMED is an important tool, an important development, and it could be a really useful tool for occupational hygiene practitioners and others in selecting and applying reliable exposure controls. And I think it has a number of features that offer great potential benefits. So once again, I'd encourage anybody who has found this interesting and would like to get involved to just put your hand up and let us know, and we'd very much welcome you. So that's it, really. Thank you very much for your attention, and I'd be pleased to take any questions if we've got time.
Okay, thank you, Andy. We've already got 2 questions, and if others would like to type some questions in the Q&A, I'll read them out to Andy. The first one is, will the COMED system, when it becomes available, be free, or will there be a fee?
Yeah, our thinking on that at the moment, we're still looking at the appropriate business model, but our thinking is that we would have a free basic version for anybody to use, that would allow people access to a lot of the information on the database, and then a subscription-based premium membership for individuals and corporations and companies to get involved, where they would have greater input and greater access to things like the grey literature, for example. So at the moment, our thinking is the COMED database will be freely available in basic form.
Now I'm going to read out a fairly technical question, Andy. Does assigning the data quality consider the treatment of exposures below the level of detection values, e.g. a study that has calculated efficiency of 90% plus, but had a significant amount of the censored data that was replaced with the level of detection divided by 2, or whichever model you use, versus a study that has a lower calculated efficiency, but used better treatment of censored data method like Bayesian analysis or ROS or high volume sampling that overcame a level of detection problems?
Yeah, great question. And the short answer at the moment is no, we haven't got to that level of sophistication in terms of analyzing the data. Nearly all the data on the database at the moment doesn't really fit into that category. That's an issue I've come across myself quite a lot in the pharmaceutical industry, for example, lots of LOD type exposure data. But the whole issue of how we rate the quality of data in each data set is really critical. It's really important, and it's something our validation team are working on, producing a really watertight system for categorizing data sets into good, medium, and poor. That's certainly an element that we need to look at and develop a response to, but at the moment it's something we've not really addressed.
Okay, then 2 questions about data quality. Who gives the data quality rating good, medium, and poor? And is there a set criteria for assessing quality?
Yeah, yes. So it's a follow-on question, really. The data quality evaluation is done through an internal audit process by the validation. Well, first of all, by the data entry people. So the volunteer network who do the initial data entry, do an initial evaluation of data quality using some basic rules that we've established. And then there's a second evaluation of the quality of the data by the validation team, who focus on that aspect and look in a little bit more detail. But to be frank, this is one of the aspects of COMED that's not quite ready yet. We still need to really finalize the data quality criteria, and that's one of the reasons why the COMED tool isn't publicly available at the moment.
A question, somebody who wants to know how to become a volunteer.
Oh, fantastic. Well, one of the easiest ways is just to send an email to me on that email that you can see on the screen now. Hopefully I'm still sharing my screen, am I?
Yes, you are.
Okay, so if you would like to send an email with your information to andyg1255@outlook.com just to express your interest. I think also Michelle has a copy of the volunteer interest form with a number of tick boxes, so you can indicate which particular aspect of the database development you would be keen to get involved with. So perhaps that can be shared to all the attendees after
Yeah,
the webinar.
it will be.
Right,
I'll
great.
send that out. I'll send that out with the survey.
Okay.
Lovely, thanks, Michelle. So 2 ways to flag up your interest in getting involved: either send me an email directly or respond to Michelle with the tick boxes after the webinar.
Next question is, how will you avoid commercial products and their supported data overwhelming data sets?
Yes. Another extremely good question. We're very determined to maintain our scientific rigor and independence from any commercial overtones, while at the same time wanting to receive any useful information that suppliers of exposure control measures might have to try and justify the effectiveness of their particular piece of equipment as opposed to others. So we don't have any direct ties with any individual commercial supplier, and we certainly don't benefit from sponsorship from any individual commercial organization, and we're very keen as independent professionals with high ethical standards to make sure that we don't get drawn into that trap, as it were.
Thanks. Next question is, what sources were used to establish the contextual information that partners the exposure results, or did the committee help to establish that?
In the main, we're dealing with information from peer-reviewed literature. So in most cases, the contextual information was available in the paper. So the paper would be read in detail and all the relevant information extracted from it. Of course, as we all know, some peer-reviewed information has more contextual information than others. So there were cases where the contextual information was limited or missing. And in that case, we didn't invent it or make assumptions and create it. So it's clear that the quality of contextual information was variable. And in some cases, there was very little contextual information, and that would result in a poor data quality rating.
Next question is, what measure are you applying in the summary for exposures before and after 95 percentile level MERV exceedance fraction?
At the moment, we're just doing a straightforward mean value of exposure data before and after, with standard deviation applied. So the mean value is fairly conservative, I guess, but the 75th percentile would be another option, or even the 95th percentile. We might be guided by some of the regulatory moves. I think under the REACH regulation, the exposure prediction models are tending towards using something like a 90th percentile value. But at the moment, we're just using a mean.
Okay. If industry participates and they share containment verification data, can the data be anonymized?
Yes, is the short answer to that. And containment verification sounds quite a lot like the terminology that's used commonly in the pharmaceutical industry. And one of our management group is very much a pharmaceutical expert, and we're looking a lot at that kind of data. There's a wealth of data in the pharma sector, for example, on effectiveness of isolators and other control measures. So we definitely want to tap into that. And anonymity, not just for pharmaceuticals, for any industry sector, any participant, is something that we understand is very important. So we already have a number of data entries which have been completely anonymized. Then normally the grey literature data, and there's no reference at all to the source of the data, just the generic process and exposure controls.
And final question, and thank you for everyone for the great questions, is it just dust chemical exposure, or does it include other hazards like noise?
Yes, at the moment it's just dust, and it's just inhalation exposure. When I say dust, it might be dust, gases, vapors. So it's inhalation exposure to hazardous substances. The database has the potential, I believe, to be extended and used for other hazards, physical hazards. Skin exposure is something else that we've been asked about in the past, in skin absorption. But they are developments that might come in the future. At the moment, our focus is just on inhalation of hazardous substances.
Thank you, Andy. I'd like to thank all the participants and the great questions they've asked this afternoon. And particularly, Andy, I'd like to thank you for getting up so early in the morning in the UK. I know for the people in happening here in Australia, this seminar was a little bit different in time zone to the normal seminars, but that was to fit in with the time. I think this is going to be a great tool for the hygienists for the future, and I look forward to when it finally gets published. Andy?
Yes, so do we all.
So I like to thank you, Andy, and I'd like to thank all the participants, and I think we might finish the presentation there.
Great, thanks, Sue.
Thanks, Andy.